Hello, everyone, and welcome to another episode of Let's Talk About AI. On this episode, I'm talking to my friend Justin, who is in a very interesting position in the scientific field and in government. And so he has a very interesting spot to see how AI is going to affect his workplace and both those really important parts of society. And we tend to drift off on that topic a bit into more of the philosophy of how AI is going to affect work and what we're going to do about it as a society. I hope you enjoy it. Thank you. Hi. Hi. Welcome to this podcast. If you can introduce yourself real fast and tell everyone who you are and what you do.
Sure. My name is Justin Goodrich. I'm a physicist at Brookhaven National Laboratory, which is a lab operated by the Department of Energy. I guess I should note that everything I say tonight or talk about tonight is really my opinion and not representative of the lab or the Department of Energy or anything like that. But I'm here excited to talk a little bit about AI and how it impacts my job and maybe any other topics you're interested in.
Yeah. Let's get right into that then, because you told me that you use AI in your job. And so can you tell me about that? Like, how does that work and what kind of AI do you use? Is it like ChatGPT or is it something else?
Sure. So I guess I could start off broadly by saying, artificial intelligence. I mean, it's kind of a large concept to encapsulate in one subject. I mean, machine learning, which is a subset of artificial intelligence, has been around for a while, and people have been using it for all sorts of things, especially in the scientific community. So the first and the most straightforward examples that come to mind are statistical analyses of like large data sets. So where I work and other facilities generate very, very large volumes of data. So we're talking about terabytes of data, potentially. I mean, it depends on what experiment where you're talking, but you can imagine terabytes of data per hour, per day, or even larger. And it's almost infeasible to actually save and study all of that data.
Yeah.
So machine learning techniques have been used to kind of filter that and classify that data on the fly. And it's actually quite powerful. That, like, the example that everyone knows and is kind of ubiquitous in this is the Large Hadron Collider in CERN, which is the largest collider in the world. They generate such a massive volume of data that it's like completely impossible for them to save everything and then sift through it after the fact. So what they do is they have machine learning algorithms, which are broadly a sense of artificial intelligence, that analyze the data on the fly, and then if it identifies something interesting in that data, it'll be saved, and then investigated further with more thorough analyses, right?
Yeah. Without going too much into the math, right? Because I want to try to keep this for everyone.
Sure.
I do know, though, that there are differences between machine learning and algorithms, right? So how is the LHC using machine learning specifically? Like, why isn't it just like if they see some kind of particle fly off, it's like, oh, you can kind of create an algorithm to notice that versus the machine learning that you're talking about?
It's a good question. So, yeah, I mean, where the boundary is between an algorithm and a machine learning, I think, is actually kind of a blurry line. So the issue for them is that they generate large amounts of data, and almost all of it is background. So they're colliding, say, protons together or something like this. I don't know the details about that because I don't work specifically at CERN or do that precisely. But broadly speaking, they will collide these particles together, and they generate tons of particles and light and all sorts of things that come out, and they have all these detector arrays that are capturing that. So they've trained certain algorithms to be able to, or certain machine learning models, I guess I should say, to what a typical background might look like. And then if they do get that 1 in a billion event thing, it'll kind of stick out, but not stick. It's like finding a needle in a haystack almost, right?
Yeah.
Because there is such a large, massive background. So the machine learning models are quite good at finding those little bits of data that are extra and kind of classifying them as such.
Okay.
So it really is a big classification problem in machine
Okay.
learning. Machine learning is very, very good at doing kind of data classification,
Yeah. Pattern
um,
recognition.
pattern recognition, right?
Right.
And finding correlations that are difficult for a human to do. Now, in principle, what you could do, I suppose, is kind of write a program that doesn't require the trained data set. You like a priori put in what you're kind of looking for,
Mm-hmm.
and then it will attempt to sift through the data and whatever conditions you're setting in the code, it'll then isolate that. Well, with machine learning, you kind of have the advantage that you can put in the many terabytes of data you do have already, and then it'll automatically kind of, maybe not automatically, but it'll without you having to put in a priori kind of what the data that you want to analyze look like, um, it'll kind of come up with that on its own. Um, so that's just one example. I can give you a couple more if you're interested.
Yeah. Yeah.
Um, so
Please.
another one is the one. This is one I have a little bit more direct experience in. Is in kind of materials and structural structures engineering. So structures
Mm-hmm.
meaning, I mean, in a very broad sense. I'm not talking about when I say materials and structures. I guess I just realized I might have given the impression I'm talking about like buildings or something like that. But I'm talking more like in chemistry.
Mm. Okay.
So there's something in. I'll just give a concrete example. So there are LEDs, right? LEDs
Mm-hmm.
are. I think everyone should know what LEDs are,
Yeah.
but
Little light bulbs.
yeah, light bulbs, but they're electronics, right? They're something we call
Mm-hmm.
optoelectronics.
Yeah.
And if you actually look at how they're fabricated, they're very thin layers of different materials that are kind of stacked together in sequences that kind of capture where the electrons that are flowing through the material, where they actually give off the light. And then
Mm-hmm.
you design these structures in order to have different efficiencies at different wavelengths, different colors.
Mm-hmm.
Um, and the full LED structure might have, like, say, 40 different layers that are different materials, different compositions, stoichiometries, as we would say in chemistry, but you could say, literally just different constituent atoms. Um, and depending on the design, you'll target a certain color. You'll target a certain output wattage, like how much light you're actually going to get from the structure,
Mm-hmm.
etc. So people design these kind of by hand and using kind of classical kind of computer, obviously, to help do the simulations. Um, but I had a case, for example, in my PhD where we had certain structures that we knew worked, and then we were building in machine learning. We were essentially building a model where we put in the structures that we knew worked as inputs, and then the outputs would be kind of some of the electronic properties of the structure. I mean,
Yeah.
the details are maybe a bit too complicated to go right into right now, but certainly like the electronic structure that they would generate, which would ultimately result in the light emission.
Mm-hmm.
And then based off of that, we kind of designed a program to reverse engineer it now. So now instead of feeding it in tons of layer like physical structures of materials and what they would do, we'd say, okay, we want a structure that does this. How
Wait.
do
Wait.
we use the AI to or the machine learning algorithm to reverse kind of give us a candidate structure that
Yeah.
might
Yeah.
have
Yeah.
that desired capability.
Yeah.
Um, so that's something that I think is really nice. It came out. I remember at the time it came up with some kind of bizarre looking structures, ones that may not be the most feasible to actually fabricate
Mm.
with current technology. But in principle, doing this kind of discovery with the machine learning is something that's really at the forefront in material science. Electrical engineering is
Mm-hmm.
kind of this field, but physics broadly, I'm sure in biology and chemistry as well, people are doing this sort of thing. Um, and then another aspect that where it's impacting the work that I've seen is kind of just doing automation. So especially for these complicated uh, uh, experimental setups. So where I work right now, it's at something called a synchrotron, which is a high energy X-ray source. And then what actually is there's many different beam lines that are around the synchrotron, um, and there's a lot of components to it to get the X-rays to be focused in at the energy
Yeah.
that you want for the biologist, whoever's coming to do their experiment. So there's a lot of effort right now in having AI tools that can automate the alignment of these beamlines. So right now, it's something that humans do.
Mm-hmm.
We'll go sit at a workstation and maybe spend half a day tweaking the positions of all sorts of optics and components within this like 80-meter stretch of
Just a
you know
very
components.
just the setup of it.
Right, right. So we say, okay, we want a beam that has 50 micron size, and we want it to be this energy, and we want it to be positioned here, and we want it to have a certain level of coherency. And again, all the details of that don't really matter so much, but there's a process. There's obviously procedures that we follow,
Mm-hmm.
but people are working on these kind of autonomous alignment systems that you kind of you would just type or tell the AI in some format what type of X-ray beam profile you would want, and then it would handle the motion of all these optics in a way that would free up a lot of, for example, my time or my coworkers'
Yeah,
time.
yeah, yeah. If it takes half a day, that's a lot of setup.
Yeah, yeah. These are quite complicated pieces of machinery, and I guess I should say, I'm a physicist.
Hmm.
I'm still learning a lot about machine learning. It certainly is not my area of expertise, but it's become so popular now
Yeah.
that there's I attend seminars or I see different talks being advertised, and more of them are including some machine learning component. A lot
Hmm.
of calls for funding from agencies that fund scientific research like to see see that you're thinking about whether or not machine learning can be incorporated into whatever
Mm-hmm.
research you're doing. There's a lot of activity. For me personally, I think I find it very interesting just from an intellectual perspective,
Mm-hmm.
the advanced nature of these things, and that I think over the past depending on what we're talking about exactly, it certainly has had a steep ascension as of
Yeah.
recently. Um, so I do find it interesting, and I'm eager to learn more about them and try to find different ways that they could be used. It definitely can be a bit intimidating because
Hmm.
Google Scholar, right? Google Scholar is kind of where researchers go to find publications that are relevant to their research, and most researchers spend a lot of time reading other people's papers and seeing what they're doing.
Mm-hmm.
And then
Mm-hmm.
when you're doing a search and you see so many different papers being published that have these different AI or ML models, it can be intimidating, right? Because
Mm-hmm.
and each one's a bit different. This one they're using some deep learning recurrent network, and then you have another paper that's doing some type of different model, and it can be a lot to digest on top of trying to just digest the science that I'm like directly
Yeah, yeah,
interested in.
yeah.
So it is a massive tool that can sometimes be a bit daunting
Hmm.
to figure out exactly how it fits into what you're trying to do.
Yeah. Um, so yeah, so first about how it makes you feel, and then like, do you think you're how do you think it's going to shape science in general in the future? Like, is it going to help you? Do you feel is it going to pushing you out? Do you think people should um, learn about AI first and before going to the sciences, or how is it going to affect the field?
I think it depends on what time frame you're talking about.
Okay,
Right,
let's
like
say 10 years.
10 years. In the next 10 years, I definitely think it's become more prevalent. For
Mm-hmm.
my very specific niche kind of job that I do, I'm not overly concerned about AI kind of eliminating my job. Main
Mm.
reason is, well, first of all, I guess this is kind of segueing into large language models a bit. The models I just described before are kind of, again, have been around for a while now.
Mm-hmm.
Like the statistical analyses, people like machines have been doing that for quite some time now.
Yeah, yeah.
Um, so you really need that extra layer of kind of world building. That this kind of
Mm-hmm.
a concept that people in the large language model community talk about, right? About whether or not these models are capable of, not only just kind of creating text, but actually having some type of physical, maybe you
World
can call it
model.
intuition
Yeah.
about what's going on. I think we're not there yet.
Hmm.
For my job in particular, there's kind of a um, in-person component to it. Like, we're loading samples, we're moving
Hmm.
equipment, where it's very much an experimental job where there's physical labor that's involved as well.
Yeah.
And not to say that I do much physical labor, but I have to be in person switching samples. You have to type on one computer and go to another computer. You have to. There's a lot of activities that are not just like software engineering, for example, where I'm
Hmm.
just literally sitting in front of like one screen. That I think it would make it difficult to be completely replaced without some type of like
Yeah.
robotic component to it.
Yeah. Hmm.
Certainly, robotics are coming, so I don't mean
Yeah.
to say that that's never going to happen. But in the short term, I think there's also where I work. There's a lot of regulations that sometimes lag behind some of the technology. Um, so I'm not concerned in the next 10 years that my job's going to go away because
When you
of
say
this.
regulations um, kind of lag behind the industry, does that mean it's like kind of protecting your job, or what do you mean by the regulations then? What
Maybe
regulate?
maybe regulations is part of it, but also we're just sometimes we're not the fastest to adapt that
Hmm.
an evolving technology. So there's a lot of bureaucracy
Yeah.
involved, at least with where I work, that
Okay.
makes it difficult for rapid changes to take place. You need to get so many approvals to do anything. Like I think that without getting too specific, like we have like this new detector that we're trying to integrate, and it's taken like quite a long time for that to happen, and it's
Hmm.
really um, just because of these kind of bureaucracy kind of
Yeah.
holdups, right? Getting approvals, doing safety checks, getting kind of accessories or different equipment that's needed to support it. Um, so we can be slow to adopt sometimes
Hmm.
what's at the very cutting edge of what's coming out of, say, these big AI based companies.
Mm.
So I think
So
that there is potential that it's going to impact my job more and more, just not to the point where I'm concerned in the next 10 years, per se, that my job is going to be
yeah.
completely automated. But more broadly over longer time scales, especially as AI become better at doing this world building. I mean, maybe I'll take a step back. So, large language models suffer right now from a lot of this, we call it like hallucinations, right? Where
Hmm.
they um, kind of make things up
Yeah.
sometimes. Um, and I mean, humans do that too, to be fair.
Yeah.
Uh,
Yeah. Yes, we do.
but it's hard to interrogate that out of them right now. Like, and I know they're getting actively better with, like, for example, the newest GPT model is
Yeah.
like, I'm sure you
Oh,
heard
one.
about this like strawberry thing, right?
Yeah. Yeah.
Where
Oh, one.
yeah, and
Yeah.
originally it would just keep tripling down on there are 2 R's or 3 R's in strawberry or something like this, right?
Yeah.
Or was it would say there's two, but really there's three, right?
Yeah.
And then you would kind of point out its flaw, and it would
Hmm.
still continue to just like really go hard on the fact that it claims that there are two.
Hmm.
So I think that is a huge. Those kind of things really need to be ironed out a lot better than they are now.
Yeah.
To uh, because right now they're just an impediment to doing like physics or some
Yeah.
type of certain, that kind of thing. Yeah.
Have you tried out the new GPT-o1 model?
Oh yes, I have. I haven't
Okay.
tried the strawberry question on
Strawberry.
it,
Okay.
but I saw that it supposedly is better.
Yeah.
Yeah, and so in terms of that, in terms of GPT, because I guess I didn't really speak to this directly yet. Um, I find it useful for doing certain coding or software engineering related tasks.
Hmm.
Um, so I do a lot of scripting, running simulations, or developing some code to do analyses, or maybe I'm just trying to generate figures for a scientific plot. And in Python, there are these libraries that are widely used to generate these kind of figures
Hmm.
with data. So I find my most common use of GPT right now, and these large language models more broadly, is kind of helping with like rather mundane scripting tasks. Often it's something that I know how to do in
Yeah.
principle, but it might take me 20 minutes to set it up.
Yeah.
And I can just kind of spend a minute or two typing out what I want,
Hmm.
maybe iterating with it a couple times. But then, on the long run, it develops very clean code that, for example, will generate some figures that I want that I could then reuse for some other purpose later.
Hmm.
So I find myself using it for that sort of test quite a bit. Um, for larger scale software engineering, kind of like if I'm really writing like a big simulation or data analysis framework, I might use it for little bits where I kind of could use a little bit of inspiration. I don't know if it's at the point yet where it's capable of generating like thousands of lines of consistent code
Yeah.
for a kind of more medium scale application. But for coming up with little bits here and there, we're trying to optimize some code that I've written in
Hmm.
my non software engineering way. Um, I find it quite useful for that. And then also just like doing some basic type editing, right? Like I write up some paragraphs for a paper or a proposal, and getting some advice from on it for grammar or something else like this. It's actually funny. I remember I was preparing a manuscript for to submit it to a journal to have them referee it, and one of my co-authors just kind of out of the blue sent me a revised version that he said, "Hey, I ran this through this AI
Yeah.
software that does
Okay.
like kind of proofreading," and he
Uh-huh.
kind of gave me like a marked up version as oh, you used the wrong word here. We should add a comma here. And again, these kind of like grammarly, these kind of things have existed
Yeah.
already. But I think with large language models now, they're getting better at understanding the context of what you're saying. So it's not just looking point by point, sentence by sentence
Hmm.
at you know, oh, you have a run-on sentence here, and it can like actually look a little bit more at the context and
Yeah. 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 Make
make
sure
sure
that
the
you're.
narrative that you're building is
Yes.
coherent.
Right. That's
Yeah.
what. Yeah. That's what I was gonna say. Um, and so yeah, if you have used O1, then do you know how it works roughly?
At a very high level, sure, but
Okay. That's
um,
basically all I know too is a high level. So it's almost like brute forcing logic.
right,
And so it does it in a way where it creates a lot of different responses, right? Like 1,000 different responses or 1,000 different ideas.
hmm,
And then there's one, like I guess separate AI or separate architecture model where it will try to choose which one sounds the best.
right, right,
And so and then it's able to come up with pretty good ideas. And so this kind of brute force method, if it progresses to the point where it can make very good code, if this is the base for their what they're calling agentic models, which is things that are able to do these kinds of tasks, these larger tasks that you said, making 1,000 lines of code and do
sure.
it consistently. If that happens, like, how do you see your department or a government specifically changing?
It's a good question. I think it will be adopted, but
Mm,
perhaps a bit slowly. So I think there's one general concern that I think some companies and agencies, and this isn't specific to federal government or anything, but have to do with data security.
mm,
So I know we're very concerned about data security. A user comes in, takes data. Like someone from the academia comes to my lab and uses our equipment to take data. They
mhm.
collaborate with me and my coworkers to do that. We're kind of specialists in the technique that they're using, and they're specialists in the materials that they're studying. Um, but they don't want their data necessarily being fed through, well, OpenAI's latest
Yeah,
and greatest
yeah.
large language model, right? So I think it depends. The adoption, I think, of these kind of more advanced language models, for example, that you were just referencing, depends on data security. Because I think, at least in my lab, again, I can't and wouldn't even know what the leadership's opinion on this would be, but I have the sense that um, they're unlikely to do a very wide adoption of kind of private, inscrutable, large language models from other companies.
If you were to have a private model, though, or if ChatGPT, or rather OpenAI or Anthropic were to basically sell you a private server
Right,
that
right, right, right.
allows you to keep all your data in close, without having to be going out to the internet or the public. Do you think it would be adopted then, or
Yeah, I think at a certain point, if its efficacy is demonstrated, then I think at a certain point, um, yeah, it'll become more and more common. And the goal, obviously, for us is to make sure that it's being used as a tool. That's how a lot of, I'd say, optimists in this field frame it. Is that these things that are being developed are going to be used as tools, just like um, I think it's kind of a rudimentary example, but like a calculator, right? Like I think that they're, and I'm not saying this is my opinion. Actually, I kind of don't agree with this, but
yeah,
kind of play devil's advocate. There were some people who kind of had the claim that I guess when calculators or something like this were being invented, or even just the internet in general, when the internet first came online, that maybe I'll phrase it like this. I remember in school that they kind of would say something like, "Oh, you need to learn how to do your arithmetic because you're not always going to have a calculator available."
yeah,
And now we live in a world where you do always have a calculator available, or like readily available anyway.
yeah.
But it was still important to learn arithmetic, I think, right? So I think that, and people today view calculators as kind of tools, that there's no real like philosophical or intellectual concern with people using calculators. Maybe some people do have those concerns, actually, but I don't think those are very prevalent in the culture.
Yeah,
And I
probably
think
not.
there are certain people, I think, who kind of have that same view of AI, that they really are going to be tools. Um, and I think in an ideal world, they would be used properly. Like that would be the case. Like, and that's kind of how it is right now with the large language models in my work. Like, it definitely is a tool. Or I've heard people even describe them in the scientific case as kind of, it'll be like your personal lab assistant. So it's kind of like I have my own, essentially my own thing that can just help me out, but isn't
Yeah.
actually directly trying to replace me. But I think at a more macro level, the concern is, um, maybe in a project 10 or 15 years ago where we would have had, a kind of collaborative team where there were maybe a couple software engineers working with physicists or other scientists to achieve some end. Maybe now, even like today, uh, why would I be incentivized if I'm writing a proposal, right? I'm writing a proposal where I'm going to get a certain amount of money per year. And I want to obviously build a team around that, for example, right? So let's say I have $1 million that I can spend on personnel costs. So I have to hire, maybe I have to hire a postdoc in physics. Maybe I'm hiring a biologist or a chemist, whatever. And maybe in a previous world, I would want to hire a software engineer, or two or three software engineers, depending on, this is kind of a very hypothetical situation. But now I might be less inclined to hire three software engineers if I'm aware of the capabilities of these programs to write decent software, and if they become more agentic, as you pointed out, and they become better at writing these kind of more medium and larger scale software, um, why would I I don't know why I
Yeah.
would want to spend half my budget on software engineering when I could maybe spend it on some
Yeah.
equipment I need, or I could
Mm-hmm.
spend it on bringing on a theorist or something like that.
Mm-hmm.
So I think software engineering in general is going to be the hardest hit in the sciences. And I
In the
definitely
near
can see,
term.
as you were alerting, as you kind of were alluding to, that even more theoretical and
Yeah.
intellectual work is coming. And I think in the long term, there's no doubt about that. I think I'm maybe just a little bit more kind of on the time frame that's probably not going to happen in 10 years, but maybe in
Mm.
20 or 30 years. I think that's definitely on the table, um, with more theory, kind of mathematical based work being
Mm-hmm.
offloaded to AI.
In that case, I actually do think it would be sooner than that. Um, and that's kind of why I'm doing this podcast, is to kind of get
Sure.
ready for that.
Well,
Um,
what I'll say is, even regardless of if it is 10 years, like maybe you're
yeah,
thinking, or if it's like 30 years, which is kind of my intuition, that almost doesn't even really matter too much, because I think
yeah,
we both agree it's coming, and it's
yeah,
coming in our lifetimes.
yeah,
So whether or not it's 10 or 15 or 20 years is almost kind of a moot point, I would say.
yeah. That's
Um,
true. Yeah,
yeah,
and I hope more people see that too, and start realizing that we should do something. So in that case, what would you do, right? If you just said you can hire a team and you can hire all these people, but then you can just choose not to. What kind of science is that gonna kind of create? Is it going to allow everyone to create their own team, or is it going to allow a few people who already have or are in those positions to make those teams?
yeah. It's a difficult question to answer. I mean, that for that the way you specifically framed it, I think it depends a lot on funding and what happens to
Mhm.
funding. I mean,
Mhm.
in principle, if the same amount of funding is available, but you don't need as large of a team, so therefore you need less funding to do your research, then maybe there are more different opportunities that are funded and
Mhm.
undergoing active research. I don't know. It's a good question. I'm not sure I have
Mhm.
an intuition about that. I mean, I think that in a very over a very long term,
Mhm.
um, yeah, there clearly is going to become a crisis where uh, there's going to be less available work for people as a whole, and then we start really having to think about, then it starts to actually get quite philosophical, in the sense that what do people do in such a world? Um, where do people
Mhm.
get? Obviously, there's the financial considerations. So, it depends on how well spread the fruits of this kind of technology is to the population.
Yeah.
But even beyond, like, I know that the most natural and concerning and in our face kind of concern is, how are people going to make money and survive, for example, in a world where less and less people are required to do the work. But even beyond that, let's say even we came up with universal basic income and everyone has like a base level of monetary support, then I really think there's going to almost become like a crisis of meaning. Like, is
Yeah.
everyone
It
going to
could.
be
It could.
happy? Just let's say everyone can just stay home and kind of do whatever they want. You want to go to the beach,
Yeah.
you want to play golf, you want to play video games.
Mm-hmm.
Um, and you are free to do that, right? Take away the
Mm-hmm.
money is even an issue anymore. How happy are people going to be
Yeah.
in that world? I mean, I think superficially, a lot of people might think, "Oh, I could just stay home and like play video games, or I could just golf all day." Like that sounds like great, but maybe after you do that for 10 years straight, you're kind of like left a little bit empty, right? Like,
Yeah.
I
Yeah.
do think that to some degree, working and having kind of intellectual stimulation
Mm-hmm.
is important for us. And I don't think,
Yeah.
just working for the sake of, because you're going to starve otherwise. Like, I mean, I think that there are a lot of terrible jobs out there, and
Yeah.
people,
Yeah. Yeah. And
but
I agree with that, and I think that there's definitely some kind of philosophy episodes that this podcast can go to that don't even really have to do with AI. It's just like, what kind of society do we want to build, right? If
right,
we get these kind of implied results of what do we do with that life if we don't need to work, or are we allowed to like choose what kind of work that we want to do? So then, let's look at the government aspect for this. Governments are notoriously slow. Everybody makes fun of that. Um, you mentioned the bureaucracy behind it, and a lot of it having to be like rubber stamps, right? A lot of things have to be approved.
Yeah.
Do you see those being automated in some way? Like, if you can just get it easily rubber stamped, like if machine learning can read a document really fast and say this is okay to be approved or not approved, do you see bureaucracy kind of becoming more efficient?
I think that would be a great use case if that
Yeah.
actually happened. I know
Yeah.
that so much paperwork is generated to do
Yeah.
what might seem a relatively mundane thing.
Mm.
So if that could be somehow automated,
Mm.
or like you said, like I'm trying to hire an intern, right? And then
Mm-hmm.
it's like not actually right now, but I have in the past. I tried to hire an
Yeah. Okay.
intern, and you know, you need to get like 8 approvals. That's like this person has to approve, and this person, and this. I see like this huge list of people that need to approve, and then what you know would essentially take like no time ends up taking like a week because it's like
Yeah.
this person has to do it first, and it gets forwarded to someone else, and then gets forwarded to someone else.
Mm-hmm.
So like if that kind of chain of events could be reduced at the very least, I think that would be a net win, and I would hope that to be the case. I do think kind of broadly in academia, um, and probably the government too. There have been kind of there's a lot of overhead, and there's
Mm-hmm.
a lot of positions that have been like if you look at a university now, for example, which I'm not in the university, but I spend a lot of time there. They're adding so many different departments and like deans. Like you have a dean of this, a dean of that, and then they all have administrative staffs, and
Mm-hmm.
that's partially what led to the rising cost of tuition. Is
Mm.
because now usually before you just had like the colleges and then you had departments and then they had their staff. Now, obviously, you probably has some support staff like in the financial aid office and admissions, etc. Right?
Mm-hmm. Yeah.
But now there are many, many different kind of departments spread out that are a little bit outside the academic, like the
Yeah.
scholastic
Academia. Yeah.
departments, I guess you could say.
Yeah.
Like I'm not talking like the Department of Math, but you have like I'm trying to think of it like large numbers of people doing human resources and
Mm-hmm.
DEI. And I'm not saying these things are bad at all, but that all this structure that's been added on top leads to a growing amount of overhead, tuition,
Mm-hmm.
costs, etc. So if some of that could be streamlined through
Mm-hmm.
AI, I think that could be um, good. It's interesting because much to this point, like if you get a grant from to do some type of scientific research, right? And you want to go back to what you were talking about before. You want to hire a postdoc. You want to hire like a PhD student. You want to hire some intern or support your own salary a bit. There's a huge amount of overhead. So let's say you're hiring a postdoc, and their salary and benefits come out to say
Mm-hmm.
$100,000, just to pick a kind of nice number. Um, the amount of money that is actually taken from your grant is usually 2 or 2.5 times that.
Wow.
So the salary and benefits, so including like the health insurance and all that, hundred
Mm-hmm.
thousand. But the bottom line of what's taken out of the money is like $250,000, for example,
Wow.
on that order, right?
Yeah.
And a lot of that goes to support this kind of administrative staff
Mm.
that is helping to run the organization as a whole. So I think that if AI could lead to cost savings, and that would
Yeah.
actually be quite beneficial to science and academia in general.
And making things go faster.
Yes.
My whole point is like government. If government also can go faster, how does that look, or how does that the ripple effects of that through other parts of society, including science? Um,
Right, right, right. Yeah, I mean, I think it's I think I share what I believe to be your concerns that the AI can lead to kind of this existential crisis and a loss of work and meaning, and people getting displaced from the job market. All these things that
Hmm.
I share them, but I also do think that there's a lot of upside as well
Hmm.
that is possible through these technologies. And this is a prime example of this. Like if you could have AI tools, um, just thinking like the Congress, right? Like they have these 1,000-page bills that they're trying to
Yeah, yeah,
analyze, and using an AI tool that can kind of sift through it, find all the earmarks, right, or all
yeah,
the
yeah.
kind of
All the,
they're passing the farming bill, but then there are bits about I don't even God knows what, right? Like
yeah, yeah.
all the things that are in there. Um, Try to make that more optimized and transparent to the public
Hmm.
and to other lawmakers or policymakers, for example. Um, I think that would be a huge boon. That should definitely save money, help efficiency, and in an ideal world, make things way more transparent.
Hmm. And then lastly, like, do
Sure.
you have any opinions on regulations, or what do you feel like should we do, if anything, to make sure that we are kind of protected, or maybe even if you think that it's good, like advance the AI, right? Protect the
So
public or advance AI.
I think there's kind of two, th- probably related, but
Hmm.
separate um, areas where you want to impose regulations.
Hmm.
So one is kind of on what, and we haven't really touched on this tonight, but I think it's very relevant for this question of regulation. Is kind of what people are calling the alignment problem, and
Hmm.
making sure that. So I guess I'll talk, before I go into detail of what that is. So there's kind of the alignment problem where we're making sure that AI actually do what they're designed to do and what we want them to do, and there's kind of the economic issue, right? That I think we were a little bit more focused on
Yeah,
today, where you're concerned about people having jobs and not
yeah.
being displaced from the workforce, and I think those are related, obviously, but
Hmm.
separate, and both require regulations to address them. Um, so in terms of the economic thing, yeah, it's tough. I mean, I am a capitalist to some degree. Like I don't know that going fully kind of uh, collectivist with it in the short term. I just don't know if it's feasible. I don't think people are going to actually do that. It's hard to imagine politically
Hmm.
and culturally people moving to a more collectivist kind of society that is like all the gains from AI are like taxed at a very high rate and then redistributed to the people. I think it could work, but I just think the change at that level that ultimately might be where we go. So like I'm just noticing above my head I have a picture of
Yeah, Star
Commander
Trek. Yeah.
Data from Star Trek, and in Star Trek: The Federation, they essentially have no concept of money, right?
Yeah.
And everyone kind of just works for their own interest.
Hmm.
But you don't have to work. All the basic commodities are provided. Like you have a replicator that can make food. I don't know how exactly. They don't really talk tons about how they deal with overpopulation or housing or living, real estate. Like that's kind of not really talked about. And I think that's something that, um, obviously we would have to figure out in a kind of society.
Hmm.
Um, I don't. I think we're far away from that actually being close to a political reality. I'm not against it in principle, like philosophically, but I think we have to figure out how to get there over a relatively long time period because I know politically right now it's like a complete non-starter. Um, so I think that as a way of maybe getting there over the long term in kind of congruence with AI really having these like very strong displacing effects that you're talking about. Universal basic income is probably a good option. I was
Hmm.
actually a big fan of Andrew Yang's when he was
Yeah.
running for president in 2020 in the Democratic primary. He talked a lot about universal basic income
Hmm.
and the benefits. Um, Especially if I remember his classic example was truck drivers, right?
Hmm.
So as autonomous vehicles become more and more prevalent, um, I think
Yeah.
truck
It's
driving
like
is one of the
millions of
largest.
jobs. Yeah.
Yeah, it's one of the largest jobs in our economy.
Hmm.
And if you know, even if not right away, it's not going to happen overnight. It's going to be phased out. There will be maybe,
Yeah.
instead
Can
of
be
having
phased
people
out.
driving cars,
Yeah.
you'll have someone kind of just sitting in the car, making sure everything
Mhm.
goes okay. And at a certain point, you'll have maybe someone at like a kind of office somewhere, maybe monitoring like 10 cars.
Yeah.
But then eventually, this, I forget, was a half a million or a million or something like this. That staff will probably be reduced down to like 10,000, for example. People
Hmm.
kind of managing high level logistics of, so a car breaks down. Okay, you have to call someone. There's still going to be some work in the short
Yeah.
medium term that a human is going to enter the loop somewhere. But as that kind of transformation happens, um, it's a tough situation, right? Because I think another thing that people talk a lot about is retraining. Like that's kind of the classic thing
Hmm.
that I think is maybe the more conservative argument is that um, you know even if you take for granted that yes, certain jobs are going to go away, that's always been the case, right? Like over the
Hmm.
course of the past 200 years, there's been innovations that have removed a working force, but then we've adapted, right? That's kind of again the
Yeah.
devil's advocate position with this. Not sure that that's going to happen 100% with this. I do think that the scope of the change that is coming. Again, maybe I think maybe 20, 30 years, you think 10, but regardless, it's coming to some degree
Yeah.
um, at some time frame that's hopefully in our lifetimes. Hopefully, meaning that we live long enough.
Yeah.
Hope not. I'm not hoping that everyone's jobs get taken away. I'm just saying that I hope that
Yeah.
it's um, that I think it is coming. So I don't know. I think universal basic income is probably the best transition technique. I do think
Hmm.
retraining is probably applicable in some cases. Like if you're a truck driver now, and your job is imminently going to be replaced by a self-driving vehicle, then maybe there's still a role for you in the interim and kind of a short time period, like
Hmm.
not a long-term period, but a short-term period um, of being one of these kind of logistics or monitors, like monitoring the different trucks or something like this. Um, that doesn't help in the long term, but at least for the person who's 50 when it happens, it'll kind of provide an off ramp for them. So I
Hmm.
think having some of these kind of off ramps for people is good. As I kind of suggested before, I do think in the long term we are going to have to find a way where the gains brought from automation technologies and AIs are kind of filtered down to the
Hmm.
people. I genuinely don't know the best way to do that is through a more socialistic kind of ownership of companies where people do that, or if it's kind of just through heavy taxation and kind
Mm.
of like a very glorified welfare state and more capitalistic system. I honestly don't know. Um, I'm not really a political scientist, and it's
Yeah.
hard to imagine that far in the future.
In my
Um,
opinion, I think it would be better to have just heavy taxation on
right,
automation. Because if you do it more of a traditional socialist, right, where you're actually saying owning the companies, right, public
right,
owns the companies, and in that definition of socialism, I don't think that would work because you are choosing like the winners, right, and if the public owns those companies, the public don't want those companies to go out of business,
right.
which might be required. So it's a better not to put your eggs in that basket and just be like, whatever, whoever wins, we're just going to tax you. Um,
Right. So kind of leaving the open market aspect
yeah,
to it, the
yeah,
free market, I guess I should say,
mhm,
um, but just having a very high tax rate specifically for revenues that come directly from some type of
yeah.
automation or
Should be
AI kind of,
automation. Yeah,
because
um,
they're going to become hand in hand, right? Like AI with
probably.
automation and robotics, like
Yeah,
it's hard to differentiate if I own a car factory
hmm,
and maybe I lay off some of my design team
yeah,
who are designing the cars because I have AI that are designing the team. But then I also have these assembly lines and like
yeah,
what already exists today with assembly
yeah,
lines. How do you just draw? Okay, this part of the revenue stream is coming from kind of traditional automation, just robots putting cars together. which happens. I mean, that happened a long time ago.
Yeah.
You don't have people putting in catalytic converters on your
Yeah.
car anymore, right? Like,
Yeah.
um, so I
Which,
think that requires a lot of thought in how you're going to
yeah.
tax that.
Yeah. And because of those reasons, I don't think an automation tax would work. I think you just tax profits, right? Whoever has massive profits, you tax them. It doesn't matter how they got them, just that
Hmm.
they do have them, and that's how you would pay for a UBI.
Right.
Um, yeah, because yeah, it would be very hard to define. That would also just be a massive hassle. Like the tax system is already kind of bloated in how we tax things. We just need to make it simple. It's like, oh, who has the money? Where are the profits? Then take those and redistribute them, rather than trying to peel off the layers of how we tax things and what we tax. It just seems complicated, and I don't think
Yes, for sure.
complications are not good in those cases, because whenever you have complications you can try to make loopholes, right? And which they have done. They've lots of people make loopholes all the time for taxes, and you want to avoid those loopholes, I think.
Yeah, I think it's the main challenge with this technology though is that you really need to get everyone on board. Like if we do
Yeah.
that in the U.S., if we set a corporate tax rate of 90%, which has been done before, by the way, right?
Corporate, I thought that
But
was individual.
or maybe it was individual. I forget
Yeah.
what the highest corporate tax rate has been. I
Yeah, I'm
used,
not sure. Yeah.
but either way, if we set a very high tax rate, like the classic conservative
Mhm.
argument is that okay, well these companies are just going to move to China or India or and like
Except, yeah.
in an AI world where especially like maybe they if they already don't have a strong attachment to the U.S. because their workforce is so small,
Mm-hmm.
I think it's a legitimate concern that you have to figure out how to make this. It really is a global issue.
Yeah.
Um,
Yeah.
so we have to be careful with the regulations in general and how they're implemented. It just doesn't push all the innovation offshores, right?
Yeah, I mean, I guess that's kind of true. The reason why I think that won't happen is because the United States will likely have a say in it as well. If this
Sure.
technology pans out to be as powerful as we might think it is, there's no way the US is going to let them just go to China or somewhere else,
Right.
because it's in their national security interest to keep it here. So they might forcefully keep it here, in which case, who knows what will happen then. But at the same time, yeah, I don't think it's going to go to a different country. Um,
Well, I mean, China is definitely doing their own AI research right
yeah.
now. I mean,
Yep, they are doing
and
their own.
they're very competitive with us in a
Hmm.
lot of the sciences. Um, I hear you.
Hmm.
I'm not saying that it's impossible, but I'm saying it
Yeah,
does require some thought. I know,
yeah.
if you just like if we just expect to heavily tax all the corporations out the blue without some incentive or
Hmm.
reason for why they ought to continue operating here,
Hmm.
I do think that you could potentially lose
Yeah,
people, or even to Europe or
yeah,
Canada.
that's
Like
true.
you need broad international buy-in to
Yeah,
regulations.
that's exactly what I was
Um,
gonna say. Because yep, that's we do need to work together, not only as a country but as a world as well. If these things become that powerful, we need to make sure we have international cooperation, um, with all of these systems.
And I think that'll actually be easier on the second issue that I raised, which was the alignment issue, which maybe we're not going
Yeah,
to go into detail here. But I think that, different countries are incentivized to they're all incentivized to prevent like an AI apocalypse kind of thing
yeah,
where that
yeah.
destroys humanity. Like, I don't think any country who is rational wants that to happen. Whereas the
Hmm.
other one, in terms of economic things, I think there is a little bit more competition between
Yeah,
countries
yeah.
who obviously want the best and brightest people and the most profitable companies to be based in their country. So that kind of creates like in a sense like an open market where are the regulations like
Hmm.
you have to balance that out, right? So I don't know. It's a very complicated situation that
Yeah,
I'm hoping that we figure out how to resolve. And
yeah.
seeing the current state of politics in the country, I'm not 100% sure that's where people are focusing right now,
I
and I
know.
think it's a shame
I
because
think, you know, though throughout history, existential crisis usually is what brings people together, right?
it's true.
from our very early stages of tribes, turning tribes into large cities is usually because there's another large city that will try to wipe you out. And then those cities go to nations and, just gets bigger and bigger, usually because there's something bigger that's trying to take you out.
Right.
And so hopefully with this possible existential crisis with AI, we will find a way to work together in that and solving those problems.
Yeah, I agree completely. I just hope that it happens fast enough, right? Because
Yeah.
we are kind of on this exponential growth
Yep.
curve right
Curve.
now.
Yes, we are.
And I think, some of the previous revolutions that happened throughout history
Mm-hmm.
did see rapid change,
Mm-hmm.
but those change maybe would happen over centuries
Well, the
or
Industrial
longer.
Revolution could be argued it was like over, 30, 40 years of just
Sure.
rapid changes of building a bunch of steam engines everywhere and just getting that done.
Right.
Um, but over 40, 50 years, a lot of damage was done to people as well. A
Sure.
lot of people had a huge um, just disruptions in their lives, and it can really ruin some people and make others, of course, they do very well. So,
Right.
and I think you want to prevent as much human harm as possible, which is what I think we should aim for. We shouldn't have an AI revolution at the expense of people.
I definitely agree with that. And I'm hopeful that that'll actually happen.
All right. Any other like final thoughts that you want to share, or anything you want to talk about yourself?
um, I don't know, I think we did cover a decent amount of
Yeah.
territory. Again, I think that there's a lot of potential in the sciences
Mm-hmm.
for AI, for new discovery, for helping create the next set of technologies that will change our lives for the better. Um, but yeah, we have to be responsible in how it's developed and implemented.
Mm-hmm.
I think we've kind of let the genie out of the bottle, so to speak. Like
Mm-hmm.
I don't think a solution that's going to be realistic is to kind of put a moratorium on AI research. I think that's just not human nature, is to kind of explore, and once people have started to get a taste of it, I don't think we're going back. So
Yeah.
I hope that the governments can come together,
Mm-hmm.
state governments and the federal government in the U.S., but then broadly internationally as well, to come up with kind of common sense restrictions on this, and to figure out economically how we want to handle this.
Yeah. Yeah.
So I'm definitely
Takes
keeping an
takes.
eye on it as someone kind of at the periphery of it
Yeah.
in my work.
That takes an educated public, in my opinion, right? Like that's we can't do this without having good public policy, and that requires an educated public to make those good public decisions.
Yes, I agree completely.
Mm-hmm. Thank you then for helping me educate and
Oh,
talk
no
about it.
problem. If you have any
Um,
other thoughts or questions, then just let me know. I'd be happy to
yeah, yeah,
discuss
yeah.
more in the
If I
future.
have more to talk about, yeah, I'll definitely hit you up for another episode.
Great. Thank you so
Yep. All
much.
right. Thank you, Justin. Thank you for listening. I hope you enjoyed it. If you want to learn more about AI, you can head over to the YouTube channel, Let's Talk About AI, where on this video I will have a bunch of links to other resources that you can learn more about AI in the description of this video. Thank you.